Okay, then our second lesson for trigonometry, missing sides. So we're looking specifically at missing sides of right angle triangles, and we want to figure out how to calculate those sides. So of course I know that we're all quite familiar with Pythagorean theorem. I know you started studying that in grade 8, so hopefully this is a little bit of just review. Pythagorean theorem, which says a squared plus b squared equals c squared. Okay, that's a rather random selection of variables. We could also call that x squared plus y squared equals z squared, or any such letters we choose, okay, where x and y and z are the side lengths. So the Pythagorean theorem says that if this is side A and this is side B, the hypotenuse side C, if we square those values will be equal, okay, a squared and b squared and c squared. It's not saying that a plus b equals c, but a squared plus b squared equals c squared. So how does that work mathematically? Well, if I look down here, let's just look at this vertical length here and this horizontal length. This vertical length has a length of 3, okay, this length is 3, and of course 3 squared is 9, and this horizontal length has a length of 4, and of course 4 squared is 16. And if we add up the squares, 4 plus 16, we get 25, okay, which is the same as the big red square there. And then if we take the square root of 25, we get 5. Or, likewise, if we knew our 25 and we had 9, if we were looking for this side length, we would say 25, right, the square of 5, 5 squared, and then we would subtract 9, subtract 3 squared, and we would get 16, so the square root of 16 is then 4. Okay, so that's how we go back and forth. In the formula, the hypotenuse is the letter C, so we can fill that in there. Yeah, these are the legs of the triangle. There's a hypotenuse and 2 legs, okay? What did the circle say to the triangle? Nice legs, okay? There's legs and there's another leg. I've been waiting all semester to use that joke. Anyway, it's bad, I know. Determine the value of x round to the nearest tenth. So here we've got the we're missing the hypotenuse rather. So we're going to add right away. I know I've got my 2 smaller sides. I'm looking for the bigger one. So the sum of the squares of the legs will equal the hypotenuse. I know I'm going to add 9 squared plus 13 squared, which is equal to x squared. And if I want to solve for x, I'm going to just simply go x is the square root of 9 squared plus 13 squared. Now if I pop that into my calculator, I can do that in one fell swoop. And I know probably in grade 8 and 9 you were asked to show all your steps, blah, blah, blah. But by now, hopefully you understand it and you can pop that in your calculator and do that in one fell swoop. So we're going to plug that in our calculator, the square root of 9 squared plus 13 squared. We get an answer here of 15.8. Okay, rounded to the nearest tenth, so of course that's 1 decimal place. If you look at question B, okay, same thing. We get x is going to be the square root of 11.5 squared plus 8.1 squared. Now again, I'm going to do this in one fell swoop with my calculator. One step. I'm just going to show you quickly how that would look with your calculator. If I turn this on, okay, let's turn the calculator on to start with. Clear. Some of you can do just like this. You can do 8.1 squared plus 11.5 squared. And you can get the same answer as me, which would be 14.1. 14.06 would round to 14.1. Or some of you are going to need, with your graphing calculator, or whichever calculator you have, brackets 8.1 squared plus 11.5 squared. Okay, so make sure you use brackets if you're not getting the same answer. Again, this is up to you. You've got to check your calculator, and if you're not able to use your calculator and get these same answers, then let us know as soon as you can, me or whoever your teacher is, and we can get you straightened out there. So our answer should be 14.1. Okay. Question C, of course, we're going to subtract. We have the hypotenuse. So we've got the bigger side, so we have to, if we look at our formula, a squared plus b squared equals c squared, if you want to put it back to the formula, this would be a squared and this would be c b squared, and the c squared is the hypotenuse. If we're solving for one of the legs, we're in fact subtracting. If you think about the algebra here, if I want to solve for a squared, I'm going to move b squared over, and that will become a minus, okay? So then we have the formula a squared equals c squared minus b squared. So in fact, x squared is the square root of 17.4 squared minus 12.5 squared. Okay, and we plug that into our calculator. Oh, and we don't need our square root sign there because of course I took the square root, and we get as an answer 12.1. Okay, 12.1. And for D, the square root of 8.4 squared minus 3.2 squared, which is 7.8. Okay, so hopefully this is quite straightforward for you. Just as a quick double check when you're solving these, clearly when you get, like we look at question B, if I get an answer 14.1, does that look at all accurate? Well, yeah, it's the hypotenuse is going to be larger than the largest leg. So if we've got 8.1 and 11.5, and this one's a little bit bigger, we've probably done something correctly. Here, my hypotenuse is 8.4, so this has to be the largest side, okay? So if you add by accident, your leg cannot be larger than 8.4, okay? Just mathematically doesn't work. So does 7.8 look accurate? Sure. So it's just sort of a double check, okay? If you want to try the next two, go ahead and pause the video and try those on your own. Okay, so hopefully you had a chance to try those, and your answers should be 36.1 and 22.2 meters. Okay, oh, and this one up here had units as well. That would be meters as well. Otherwise, if no units are given, it's just whatever units. Okay, we could write units. Okay, this one did have meters. So there's our units there. Now, the next type of thing we're asked to find is, again, we're asked to find sides where we only have one given side. Okay, so if we only have one given side, we certainly cannot use Pythagorean relationship because we don't know what the other two sides are, and we can only solve for one unknown at a time. But if we know this particular angle, then we can use our trig rules and our ratios using SOHCAHTOA. So here's the thing. First thing we want to do, double check that your calculator's in degree mode. We've done that. Okay, check. Label the triangle in relation to the given angle. So this again is the most important thing. If we're able to label a triangle with respect to opposite, adjacent, and hypotenuse, we are good to go. So let's do that right now. This triangle here, this would be our opposite side, this would be our hypotenuse, and this is our adjacent. The next thing I want to do is select the appropriate ratio. This is the missing side that I'm looking for. I'm looking for side X, and I have side 10. So I'm looking at using the adjacent side. I want to find the adjacent side, and I've got the hypotenuse. The opposite side, I don't care, don't want it, don't care about it. I'm going to ignore the opposite side. So if I only am concerned with the adjacent and the hypotenuse, I look up at my ratios and I say, which ratio involves the adjacent and hypotenuse? Well, that is, of course, the cosine ratio. I come down and let's write out, let's get back to question A, and let's write out our appropriate ratio. And this is how we set them up every single time. Once we've decided what ratio we're using, I go cosine of blank equals blank over blank. And what goes in these second blanks, the over on the right hand side is the adjacent over the hypotenuse. What goes in the first blank? The angle, or the reference angle. In this case, my reference angle is 26 degrees. So let's fill in what we need. I know that it's cosine of 26 degrees is the adjacent side over the hypotenuse side. Okay, so now what I've got is I've got a fraction on the right-hand side, and on my left-hand side, I actually do have a fraction as well. Okay, this is a denominator of 1. So now I've got a fraction, an equal sign, and a fraction. And if I have a fraction and an equal sign and a fraction, that's of course a proportion. Okay? And how do we solve a proportion? Well, easiest way in the world is by cross multiplying. So I'm going to go 1 times x, and it goes to 26 times 10. So I just have to be careful. It's 1 times x, which is of course x, and it's the cosine of 26 times 10. Not 26 times 10, but the cosine of 26. And the cosine of 26 degrees times 10. So now when I open up on my calculator, I'll just show you how to do this. When I push cosine, sometimes a little bracket will open. I need to close that bracket, okay? So let's go into our calculator. I'll double check my mode. Oh, because my calculator was off, I'm now in radian mode. I'm going to go back to degree mode. I quit out of there, and my equation was cosine of 26. I close that bracket and I multiply by 10. My answer is 8.987. So we had x was 8.987, and we want to round our sides to the nearest tenth. So of course 8.987, this 8 will make this a have to go up, so it's 8.9, so that becomes 9.0. Right? If this is bigger, then you have to look to the next number. 89 becomes 90, so 9.0. And we would, in fact, if we were actually being marked for rounding, if we didn't have this 0, we would be, in fact, marked wrong, because we need to indicate that we've rounded to the nearest tenth. So our answer would be, our correct answer, rounded correctly, would be 9.0. Okay? Now, let's look at question B. I'd like to give you a chance to set these up. So why don't you set up and look and see. I want you to label the triangle and figure out what ratio you're going to use. Okay, let's label the triangle and figure out which ratio you're going to use. Pause the video and do that now for questions B, C, and D. Okay, so for question B, we have the opposite side and the hypotenuse side, right? We have the opposite that we're looking for, and the hypotenuse is given. I do know this is the adjacent, but I don't care, don't want it, don't need it, don't care. So I'm looking at opposite and hypotenuse. So when I look at my acronym SOHCAHTOA, I know I'm going to need the sine ratio. So I always set these up the same way. I say the sine of blank is blank over blank. Well, what goes over here, this is the ratio, okay? The sine of the given angle is whatever ratio. So opposite and hypotenuse, that's x over 24, and my angle is 32. The sine of 32 means that my opposite over my hypotenuse, my hypotenuse is 24, my opposite is going to be what? Well, now I've got a proportion because I've got a fraction, an equal sign, and a fraction. So again, we're going to cross multiply. And when I cross multiply, I'm going to get 1 times x, which is x, and sine of 32, closing that bracket, times 24, okay, times by 24. And so when I plug that into my calculator, sine of 32 times 24, sine of 32, close my bracket, times 24, enter, we get 12.718, so that's going to be 12.7, okay, 12.7, and I guess that's centimeters in this case. The other one didn't have units, so we could just say units here for question A. Question C, right, this is the adjacent side and the hypotenuse, so that's cosine. Cosine of blank is blank over blank. What goes in the first blank? The angle, 27. The adjacent is 8.2, and the hypotenuse is x. Now again, we're going to cross multiply because this is still a proportion, but on this particular one, our x is on the denominator. So when we cross multiply, cos of 27 degrees times x, well that's of course cos of 27 times x, and that's equal to 1 times 8.2, which is simply 8.2. And if I want to isolate the x, this is just like saying 2x is equal to 10. I would divide both sides by 2, and we would get x is 5. But instead of dividing by 2 here, or 27, we're going to divide by cosine of 27. 8.2 divided by cosine of 27. Here, we're left with x, and 8.2 divided by cosine of 27. We just plug it in just like that, is 9.2. And so our answer here is 9.2 units, whatever those units might be. Let's look at the last question. I'm going to use tan because I have the opposite. I'm looking for the adjacent. The hypotenuse, don't care, don't want it, don't need it, ignore it. So I know I'm going to set up my ratio again as tan of blank is blank over blank. Here's my ratio, opposite over adjacent. The first blank is where the angle goes. So let's plop our angle in there. Our tan of 53 is 4 over x. Okay, and this is another one we're going to have to divide. When our x is on the denominator, we're going to end up dividing here. So when we cross multiply, we get tan of 53 times x, and we're going to multiply 1 times 4 to simply get 4, and we divide both sides by tan of 53. And x is equal to 4 divided by tan of 53, which is equal to 3.0, 3.01, which rounds to 3.0. And this one is inches. Okay, if you would like to try the next 4 questions, that would be excellent practice. And if you're able to get those answers, great. If not, again, contact us right away. But this is pretty much the test of whether you can do trig or not. So pause the video and try the next 4 questions. Okay, so hopefully you got these answers. Just go ahead and pause the video if you need to check your work. Okay, and then let's do the last question, example number 3. It says determine to 1 decimal place the length of the hypotenuse of triangle PQR, in which angle PQR is equal to 90 degrees, angle PRQ is 28 degrees, and PQ is 15.6 millimeters. So let's just draw any old pretty much random right angle triangle. Okay, I don't really know what it looks like, but I'll just sketch something here. And so if we do this, we know that this is our 90-degree angle. Okay, angle PQR. So when I'm labeling, this could be PQR. And the reason I know that is because our middle angle, our angle Q, okay, this could be called angle Q or angle PQR or angle RQP. So that's our angle here, angle Q, which is 90 degrees. And we can also call that triangle PQR. It could be called triangle RQP, QRP, it doesn't matter as long as it's got those 3 letters in it. And then angle PRQ, well, it's really the middle. It's angle R, which is 28 degrees, okay? So this could be called angle R, or angle PRQ, or angle QRP. And really, it's just that middle letter there. So here's our 28 degrees, and of course PQ is that side length, so PQ is 15.6 millimeters. And we're asked to find the hypotenuse. So the setting up of the triangle was probably the most difficult part here, so hopefully you're able to follow the reasoning there. This side here would be the opposite, and we're looking to find the hypotenuse. That's our missing side, that's our x. So what ratio are we going to use? We're going to use the sine ratio, and we're going to set up our ratio sine of blank is blank over blank. So that's 28 degrees, which is 15.6 over the hypotenuse. There's our x, and when we cross multiply, we get an answer of 33.2, and I guess the units are millimeters here. So there's our x value, okay? When doing the assignment question, I would do questions number 1 to 4 on the assignment. Okay, that should be plenty. And again, this should be something you can zip through pretty quickly. If you're struggling at all, contact me right away and we can clear up any misunderstandings. And let's just make a second word for this week's password. We've got excellent, and how about excellent brain? You've got an excellent brain. I don't know, I just made that up, but I think it's true. And with your excellent brain, you've got an excellent opportunity to do well So, good luck with your assignment, and if you have any questions or concerns, please contact me right away. Thank you.